Alright guys, so in this video we'll be discussing Poisson distribution in Python Numpy library. We will also be discussing the difference between Poisson distribution and normal distribution, and we have already discussed in the previous video that what is normal distribution and how you can generate normal distribution using Numpy library. And apart from that, we'll be also going through difference between Poisson and binomial distribution. Now let me zoom in by pressing Ctrl and moving mouse wheel. Okay, so here as you can see that the Poisson distribution is a discrete distribution. So the first thing that you have to remember about Poisson distribution as a statistic, it will be that it is a discrete distribution. Now, Poisson distribution are used to calculate the probability of an event occurring over a certain time. The interval can be, not time, it will be the interval, and the interval can be one of time, it could be area or volume, or it could be distance. Now, what does it mean? It means that Poisson distribution can be used for calculation of probability of an event that occur over time or area or volume or distance. Okay, you can find the probability of an event occurring is found using the formula in the Poisson distribution formula image. We will see it. It estimates how many times an event can happen in a specified time. For example, if someone eats twice a day, now what is the probability he will be eat thrice? Okay, now whenever we use Poisson, then it will take two parameter. One is lamb, second is size. Lamb is the known number of occurrences and size is the shape of data points. So let's take an example. It says that generate a random 1/10 distribution for occurrence 2. First thing, from Numpy import random. First thing first, then we'll say that x will be equal to random dot, this time we'll be using random module function, that is Poisson tab, and tab it will automatically suggest you. Now as we have mentioned that it take two parameters, first is lamb, and this will be the known occurrence of your probability. So the occurrence will be 2 is according this question, and the size will be 10. So if I print out, what we'll see, as you can see here, we have we have seen 10 times occurrence of probability, but each occurrence of probability is 2. So we have seen here that we have 2 and 1, 3 times 3, and 2 times 2, and 4 times 3. So in that way you can see that how can you use this Poisson function of module, random module, and you can easily generate any type of Poisson distribution. Now let me explain it further, the what is Poisson distribution. For that we'll have to visualize it. So I have imported these three libraries from Numpy, import random, then matplotlib and seaborn. If you don't know what is matplotlib and seaborn, then you don't worry, skip this part, just focus on Poisson distribution. These two libraries are nothing but they are used in machine learning for visualization. So if I remove this from here, this part, just remove me this part, and I'll say x will be equal to random dot Poisson, and within this should be Poisson. Yeah, let me tab it again, Poisson, and within this Poisson will pass lm, let's say 2 times occurrence. This is the known occurrence of your probability, and the size will be, let's say, 100. Okay, after that let me print this x. First we will see it. As you can see, a bit zoom in, as you can see right here, we have 100 data points, and each data points occurred 2 times according per this Poisson equation, this Poisson function. So here we can see we have in this line 2 times 3, 2 times 1, 4 times 1, and again here 2 times 3. Now let's check that how many points are mostly occurred, how many probabilities are mostly occur in this. So for this we need to use Seaborn. So SNS.this plot. Now I'm going to visualize my data. So this plot, and within this plot I will pass X. Okay. Let's say after that plt.show function and run. So SNS is not defined. So we have to, where are you? We have to run this cell. Okay, after running this, now run this one. As you can see, we have plotted this histogram using SNS. Now here, as you can see, 2 is mostly occurred. 2 is mostly occurred. So let's check. Let me comment it out this line. Now again, let me print just X. As you can see here, 2, 2, 3, 4 times 2, again 2, again 2, 2, 2, 2, 2, 2, 3 times 2, and everywhere is 2. So it's mean that whenever we use Poisson distribution, there will be a point which will occur mostly than the others probabilities. So in that way you can also check the visualized form of your Poisson data distribution. Let me control Z, control and forward slash, so that it could be uncommented. Now, what is the difference between normal and Poisson distribution? So we have discussed in the previous video that normal distribution is continuous data distribution and Poisson is discrete. So this is the difference, nothing else. But we can see that similar to binomial, for a large enough Poisson distribution, it will become similar to normal distribution for certain standard deviation and mean. Now let's check the difference between these two. So let me create here. Let me create two arrays. Two data distribution. One will be, let me give it a name. One will be normal by the name of normal, and here I will say random dot normal function. And now we have discussed that normal takes three things. First, mean, and we represent mean by LOC. Let's say I am going to give it mean 7. And the second will be standard deviation, and we represent standard deviation right here by scale. So let me give it 10, and size will be, let's say, 100. The same thing I will do for Poisson distribution. So random, then Poisson, and Poisson take LM, the known occurrence of probability. Let's say it will be 2, and size will be equal to, let's say, 100. Okay, so after that we will plot them. Nothing else. So here I will say that SNS.this plot, and within this plot I will pass normal. Okay, normal, and label will be equal to normal. So if I plot it, okay, let me use here plt show. So if I plot it, so this normal distribution will provide me this data distribution, and here you can see 10 is mostly occurred. 10 is mostly occurred. Now you can do the same thing for just copy paste this line, control C and V. So let's change the function. They're not function, the data in place of normal. Now paste this time Poisson. Okay, Poisson, and run it. So you can run it by shift and enter. So the second graph will be for Poisson distribution, and here you can see we have 1. This means that 1 occurred in most cases. Mostly occurred probability is 1. So in that way you can also check the difference between Poisson and normal distribution. Now it's time to check the difference between Poisson and binomial. So you can also study it right here. It is nothing but it is the difference between binomial distribution is for discrete trials. We use binomial distribution for discrete trials, and we have discussed it as well in the previous video. In other case, Poisson distribution is for continuous trials. So let's use the difference, and I have already used the coding. First, we have imported these three libraries: the random, matplotlib.pyplot, and Cpon. After that, I use the same SNS displot, in which I have passed this random module, and from that I have used the function binomial for binomial data distribution and Poisson for Poisson data distribution. Now, in previous video, we have discussed that binomial distribution take three parameters. First is n. This is the number of trials that you want from your probability from your data distribution, and I want 1000 out of 1000, and the probability will be 0.01 or just 0.1. Label will be binomial. The same thing I have done for this SNS. So let's shift and enter, and let's see the graph. The first graph, histogram graph for Poisson, sorry, not Poisson, that was binomial data distribution. So it says that 10 is the most occurred value in your binomial data distribution, and you can also check the other one right here. So in the next video, we'll be discussing uniform distribution in Numpy. So if you like my videos, then kindly subscribe this channel and access this Numpy playlist so that you can easily watch all the videos and all the topics of Numpy library right from the beginning. So see you in the next video.